session, I'm going to explain about Cortex M3 processor applications and then architecture of Cortex M3 processor. Okay, now I'll come to that first applications of Cortex M3 process. Mainly, we have 5 main areas of applications. The first one, it is called as low cost microcontrollers, and then it become automotive, then it support for data communications, and it helps to the industrial control. So finally, consumer products. So Cortex M3 processor is ideally for wide variety of applications. So now I'll come to that first one, low cost microcontroller. The Cortex M3 processor is ideally suited for low cost microcontrollers, which are commonly used in consumer products from touch to electrical appliances. It lower power, high performance and easy of use. The advantages of this Cortex enables embedded developers to migrate 32-bit system and develop product with ARM architectures. So means that it support for lower end applications from touch to the electrical appliances. That is what is called as low cost microcontroller. The second one, it is automotive. The Cortex M3 processor is in the automotive industry. This processor has very high performance efficiency and low interrupt latency. The latency is nothing but delay, low interrupt, delay, and it allows to be used in real-time applications. Nowadays in the market, the available these major devices, it may be embedded system or it may be a real-time system with the help of this Cortex M3 process, including our cell phone. Cell phone is also part of that Cortex M3 process. Cortex M3 processor is a support to that cell phones. So these Cortex processor is a small part in any devices or any controller. Means that it's a part of almost all real-time embedded systems. But it performs very high efficiency. Okay, this is what is called as automation. So now I'll come to that data communications. So what we mean by data communications? Data communications means the processor low power and high efficiency coupled with instructions in the thumb-2 technologies, and thumb-2 for bit manipulations, because Cortex M3 support for bit manipulation instructions. More than 90% of the instruction is related to the Cortex instruction, belongs to the bit handling instructions. They make the Cortex M3 ideal for many applications such as Bluetooth and ZigBee applications. So this is what Bluetooth and ZigBee application also become very popular. So that is what this Cortex M3 support for data communication applications. Okay. Now we'll come to that industrial control. So what for these industrial control? In industrial control applications, simplicity, fast response, and reliabilities are the key factors of this industrial control. And some interrupt features, low interrupt latency, and enhanced fault handling features make it a strong candidate in the area of industrial control. So nowadays, industrial control by using microcontroller. Even though field of mechanical, they introduce one domain or one branch that is called as mechatronics. Almost all mechanical devices or instruments controlled by these kind of microcontrollers. That microcontrollers, it may be a Cortex M3 process. That is what this Cortex M3, it support for industrial control. Okay. The last one, it is called as consumer products. So in this consumer product, in many consumer products, high performance microprocessor or microcontroller is used. The Cortex M3 processor, being a small processor, is highly efficient and low in power and support an microprocessor unit, enabling the complex software to execute while providing the robust memory protections. Okay, these belongs to that consumer's product. In the real-time application also, the latest devices in home appliances or any device related to the consumer products. Cortex M3, it is very useful and it helps to that to support for such kind of applications. That is what is called as a consumer product. So the consumer product, not only the specifically one or two products, many consumer products, they are going to use it. Okay, are you clear this? This is what the Cortex M3 processor application, main application. So now come to the conclusion of the application of Cortex M3 processor. Cortex M3 processor is support for different area of applications or different domain of applications. The main domains we listed out few areas. In some areas are some parameters to be considered. One is low cost, second one is automotive, third one is data communications, and fourth one is industrial control, and then fifth one is consumer products. So these are the major application areas. Okay, these are already many Cortex M3 processor based product in the market, including low-end products priced as low in small rate, that means less than $1 in the US dollars, making the cost of ARM microcontroller comparable to or lower than that of many 8-bit microcontrollers. Okay, now I will go to that. The next, the important slide, it is Cortex M3 architectures. So what for these Cortex M3 architectures? So these Cortex M3 architecture, each parts of the controllers highlighted in this block diagram. So we'll going to discuss one by one. One is called as interrupt controllers. That is nested vector interrupt controllers. The written as within the bracket. And then industrial, the instruction fetch unit, decoder part, like a process, register banks, some of the ALUs, and some of the interfaces they are using for that. These are all belongs to the processor part. The processor part is very simple: register, instruction, fetch unit, decoding, and ALU. So for this processor to interface with the memory unit by using memory interface. Along with that, memory protection unit, we are going to use the memory protection unit to protect the memory part. In the memory protection unit, again we have that instruction bus and data bus. Data bus carries the data from CPU to the bus interconnected peripherals, and instruction bus is nothing but address bus. In microprocessor is called as address bus, but here it is called as instruction bus. Is connected to the bus interconnect to the process. And the other some of the blocks in the architectures that is called as code memory, of course, to store the program using code memory, and then memory system and peripherals, memory system and peripherals. So it may be here we can use some external peripherals also. The memory related peripherals we are going to use, that is called as memory systems and peripherals, and then private peripherals. Some of the peripherals we are going to connect, that is called as a private peripherals. And the important part of the architecture is debugging system. So it is inbuilt. Debugging system is inbuilt. Some other controller they are using externally the debugging. By here have inbuilt debugging system. It support to trace out the program, maybe line by line programming, or trace out that inside the controllers. Everything is happens through debugging system. If you have the debugging system, of course, one additional interface is required, that is called as a debug interface unit. So these are the major and main parts of the architectures. So now I'll come to the one by one. For that explanation purpose, now we're going to discuss about that. So next part will become to the registers. So some of the registers we are going to discuss. So all parts of these architectures I will going to discuss one by one. Now here the Cortex M3 is a 32-bit microprocessor, or it may be called as a microcontroller. It has 32-bit data path. So already I explained during in the features of Cortex M3 process, and 32-bit register banks and 32-bit memory interface. These are the very important and essential to applicable in these architectures. And this process it support for R-word architectures, because these R-word architectures almost many microcontrollers they have the R-word architectures. The reason is very simple. It supports for both data memory as well as code memory, or we can access data memory as well as the code memory. In these R-word architectures, data memory and code memory is separate. Data interface and code interface also separate. If using the R-word architectures, we can interact or become very fast. Likewise, parallelism or pipelining concepts. It is three-stage pipelining in these architectures, or in this processor it support for three-stage pipeline. Separate memory have for data memory as well as the code memory. But in case of other architectures, it's called as a one-human architecture. They have common memory for data or code. We can store the data as well as the code by using common memory. But here we can save separately. We can store separately. Data memory and code memory is different. So here we can in these architectures we can use separate instruction bus as well as the data bus. They support for parallelism and pipelining concepts. Okay, and then this comes to that the instruction and data access to takes place at the same time. So here data access and allows the instruction inside the processor to takes place at the same time, and as a result of this the performance of the processor increased because data access to do not affect the instruction pipeline. So here the processor is increased because data access do not affect the instruction pipeline. So it will not affect for that. So as usually it will be running, even though pipelining without affecting the performance and all these things. Okay, now I'll come to that. Here, the instruction and data bus share the same memory space. It is called as unified memory system. Another name of this concept is called as Harvard architecture. In other words, you cannot get 8 GB of memory space just because you have separate bus interface. For example, the applications that require more memory system features, here the Cortex M3 processor has an optional memory protection unit. So here, of course, inbuilt memory, but it's called as optional memory unit also. It is wherever we require, we are going to use, and it is possible to use an external cache if it is required. Its support for both Little Indian and Big Indian memory systems are supported. So this controller, it support for both Little Indian and Big Indian concepts. Okay, in the future classes, I'm going to explain about that Big Indians and Little Indians. So now I'll come to that, the register part of the Cortex M3 process. Okay, so here some of the registers like R0 to R15 registers. Out of that R0 to R15 registers, R0 to R13 or R0 to R12 belongs to that general purpose registers. So totally 13 registers are general purpose registers, and registers 13, it is called as a stack pointer. It is out of 32 bits, 16 bit is called as a main stack pointer, another 16 bit is called as a process stack pointers, and R14 link registers and R15 program counter registers. So once again, I'll explain about the registers with in details. This is what the representation of registers in the architectures. The Cortex M3 has a register R0 through R15. Out of that, R13 is a stack registers. That is what main stack and processor stack. And R0 to R12, they are the general purpose registers. These are all registers belongs to the 32-bit register for data operation. Some of the registers have 16-bit instructions, can access subset of these registers, that is called as low registers. From R0 to R7 registers, it is called as a low registers. Low registers means they are the subset of the thumb instructions. It is called as a low registers. And similarly, R8 to R12, they are called as I registers. I registers means they support for thumb instruction registers, 32-bit registers, of course. And then in stack registers, the main stack pointers. The main stack pointers is used by the operating system and exception handlers. In the register R3, it support for the stack pointers. In the stack pointer, we have two things. One is called as a main stack pointer, another one is called as a process stack pointer. The main stack pointer used by operating system and exception handling. So this is very important in Cortex M3 process. What do you mean by exception handlers? Some of the exceptions are rising during these executions. So we have the exception handlers in this controller. We can easily manage all these exceptions, or otherwise the program execution is stopped. arithmetic exceptions, memory exceptions, some different kind of exceptions are there. And exception vectors are there inside the controllers. They are going to manage or they are going to handle. Everything it will be controlled by this main stack pointer rule. And second one, process stack pointer. The process stack pointer, it support for application code, means that is used by the application code. Okay, the stack again here, main stack pointer and process stack pointer. But generally in the stack pointer, we are using the two instruction. One it is called as a push instruction, another one it is called as a pop instruction. We can store the data into the stack by using push instruction. We can retrieve the data from stack by using pop instructions. These are the two instructions is very essential and very useful. Okay, now I will come to that. Next instruction, it is called as R14 instruction. What for these instruction? It is called as link registers. When a subroutine is called in the main program, when the subroutine is called, the return address is stored in the link registers. Because in any program, we have to use subroutines or subprograms. Once you have to go to the subroutines, the return address return back to the main program. Once complete their subroutines or execution of the subroutine part is completed, return back to the main program. During that time, the return address is stored in these link registers. So very simple, easy to remember. It link between that subroutine to the main program. Get my point. Now the another last register that is called as program counters. The program counter is a current program address. It's specifying the current program address. Then it fetch the next instruction to be executed. To be decided which instructions to be executed next. It will be decided by this program counter. Even in the microprocessor or in any microcontroller, the program counter role is very important. Okay, and along with that, some more special function registers are there in this process. So step by steps, I'm going to explain all these operations. Okay, now according to that, in the previous slide, so we'll specify R0 to R12 as a general purpose register. So these are all 32-bit registers. From R0 to R7, they called as low registers. It is nothing but 32-bit registers. And from R8 to R12, they called as high registers. It is nothing but 32-bit registers. Okay. Then this is what the stack pointer, what I explained that already. Okay. Two stack pointers, they are banked so that only one is visible at a time. We can use only one at a time. Main stack pointer is used by operating system like kernel and exception handlers. Then process stack pointer used by user applications code. The lowest 2 bits of the stack pointer is always 0. The lower bits of the stack pointer is always 0, which means they are always word alignment. They are always word alignment. Okay. Now these are the link registers. Okay. R30, R14 and R15 is the program counter registers. Okay. These are the things it will be related to that general purpose registers, link registers, program registers and stack pointer registers. So now next, one more another set of registers are available that is called as special purpose registers. So what exactly the difference between general purpose registers and special purpose registers? These general purpose registers, they are more flexible. They support for all general applications. But special purpose registers is not like that. Particularly the special purpose register, it support for some specific operations. Specific operation is nothing but only limited. Like some devices we are using use and throw device. They are only specific devices. But some devices they are flexible. Can replace some of the components and then we can utilize it. Likewise, we have the option is available. Such registers or such kind of registers is called as general purpose registers. But some registers they are not perform general operations. They perform only specific operations. Okay. The next session I'll going to discuss about that specific registers or special function registers. They perform only specific operations. All these things I will going to discuss one by one in the futures class. Okay. Now I will conclude these today's sessions. So today's I'll started with applications of Cortex M3 process. So mainly it support for 5 applications: low cost microcontrollers, automotive, data communications, industrial control, and consumer product. In the examinations, you have to elaborate about to that each applications. Usually minimum 5 marks questions from this part. And after that applications, I started with the architecture of Cortex M3 process. So main blocks of the architectures I was explained. Okay, each block we're going to discuss one by one. And today's I'll started after the architectures some of the registers. So all these registers, general purpose register from R0 to R50, including stack registers, link registers, and program counter registers, everything I was discussed. Okay, thank you. Thank you very much. I will continue in the next class.